Hello students, today we will talk about second numerical of friction chapter. So let us read the statement. What he says: determine whether the block shown is in equilibrium and find the magnitude and direction of friction force when theta is equal to 25 degrees and P is equal to 750 Newton. Take coefficient of static friction as 0.35, coefficient of kinetic friction as 0.25. So we are given one diagram. In this diagram, one block is shown which is placed on inclined surface, and the angle of that inclined surface is given as 25 degree in the statement. Then on that block, one horizontal force is acting which is labeled as P in the diagram, and its magnitude is mentioned as 750 Newton in the statement. And in the diagram, one more force is shown, that is the weight of the block 1200 Newton. It is acting in downward direction. Now apart from these, we are given coefficient of static friction and coefficient of kinetic friction, and we are asked to find whether the block is in equilibrium or not, and then we have to find the magnitude and direction of the friction force acting in this particular problem. It means first of all we have to find whether this particular block is in equilibrium or not. Then for that, the very first step is that we have to draw its free body. So let us draw its free body. So how to draw the free body? We will first label the axis, not the axis, sorry, the inclined surface. Then we will show its inclination. So its inclination is mentioned as 25 degrees. So let us show that value over here, 25 degrees. After that, we will label the block in the free body. Now let us label the forces given in the problem in the statement. So what are those forces? First is its weight, 1200 Newton, acting in downward direction. So we are showing that weight in vertical downward direction. So over here we will label 1200 Newton. Now apart from this, there is another force acting in the problem, that is the external force, which is a horizontal force acting on the block. So let us label that force as well. So its magnitude is mentioned in the problem in the statement as 750 newtons. So directly write that value over here, 750 newtons. Now apart from these two forces, we have to think about what other forces we should label in this free body. So next force we will label as the normal pressure. So normal pressure always act at 90 degrees to the surface. So over here surface is inclined, so you have to show normal pressure at 90 degrees to the surface. So let me label this as N. After this, we have to think about the friction force. Now if you see this problem, we are not sure that whether the block is moving or not, or is it moving in upward direction, or is it moving in downward direction, or is it in equilibrium. So we don't know anything at the start. So in such problems, we have to make one assumption at the start regarding its motion. So we have to assume that block is moving, let us say, in upward direction. So if block is moving it in upward direction, that is just an assumption made by us. So opposite to that motion, friction will act in downward direction. So we'll label F in downward direction, and it will be tangential to the inclined surface. Now after labeling these forces, we have to consider x-axis and y-axis. That is a very important step of the solution. Now what you should do, along the surface, that is inclined surface, we will consider x-axis, and normal to the surface we will consider y-axis. So always consider x-axis along the surface and y-axis normal to the surface. Now after this, what we will do, we will think about these forces again. So if we will see the friction force is purely acting along x direction. It means it will have no component along y direction, so no need to resolve friction force. If you see normal pressure is acting along y-axis. It has no component along x-axis. So no need to resolve normal pressure as well. But if you see this particular external force, that is 750 Newton, it is acting at some angle to x-axis and y-axis. It means this will have two components, one along x-axis, another will be along y-axis. It means next step in the free body is we should label the components of this particular force. So how to label? Now this is the point of application of this particular force. So from that point we will draw two dashed lines. One will be along x-axis, that is along x-axis or along the surface. From that point of application we will show the second component normal to the inclined surface, or along y-axis. Now you see the arrowhead for this particular force is pointing towards point of application. So in these two components also arrowhead will point towards the point of application. Now if this angle is theta 25 degrees, by geometry this angle will also be 25 degrees. So if you want to consider this angle, so this axis will become cos axis, this axis will become sin axis. So we will label this component as 750 cos 25 degrees, and we will label this axis 750 sin 25 degrees. Now let us move to the last force. Now 1200 Newton force is having angle with x-axis and y-axis. It means we have to resolve this force also into its components. So let us say this is the point of application of this force. So from that point of application we will draw two components. One will be along y-axis, that is normal to the inclined surface. Another component will be along x-axis, that is along the surface. Now arrowhead is pointing towards the point of application. So in these components also arrowheads will be towards the point of application. Now another thing to understand, if this angle is theta, by geometry this angle will also be theta, that is 25 degrees. Then this is cos component, this is sin component. So let us label this as 1200 cos 25 and this will be 1200 sin 25. Now we are done with the free body of this particular problem. See, in every problem of friction, free body is very important. So you must draw free body clearly and it must be correct. Now let us discuss about the logic which we have to apply in order to get the answer for this particular problem. Whenever you have to solve such problems where you have to find whether the block is in equilibrium or not, then after drawing the free body you have to make one assumption. In that assumption you have to assume that block is in equilibrium. So what we will do, we will assume that block is in equilibrium. So if block is in equilibrium, then we will be able to apply two equations. One will be summation fx is equal to 0. Second will be summation fy equal to 0. So from this particular equation, we will get to know that how much friction force is required in order to maintain the equilibrium for this particular situation given to us. Then this particular equation will give us the value of normal pressure. After getting the value of normal pressure, we will find what is the maximum frictional force actually acting for this particular situation given to us. If the value of this particular friction force calculated earlier, which is the frictional force required to maintain the equilibrium, is lesser than the value which is actually acting in the problem, then we will say our block is in equilibrium. But if the required value of frictional force for maintaining the equilibrium is greater than the value which we have calculated for maximum static friction acting for this particular situation, then block will be in motion. So let us apply the logic, same logic. So what we will do, we will first use first equation, summation fx is equal to 0. Now this equation tells us that whatever forces which are acting along x direction, add those forces and equate that sum equal to 0. Now you see in this particular free body there are three forces which are acting along x direction. One is 1200 sin 25, 750 cos 25, then frictional force. Now any force which is acting along right direction, we will consider those forces positive. Any force which is acting towards left direction, we will call that as negative force. Fine. So if we have to write the equation over here, we will say 1200 sine 25, then minus 750 cos 25, then frictional force plus F is equal to 0. Then we will find the value of F from this particular equation. So we will call that frictional force required to maintain the equilibrium. So when you will solve this, you will get value as 172.58 newtons. Then we will use the second equation. We will say summation Fy is equal to 0, means whatever forces in the free body which are acting along y direction, add those forces and equate their sum equal to 0. So how many forces are acting along y direction? 1200 cos 45, cos 25, 750 sin 25, and normal pressure. So these two forces are acting in downward direction. We will consider these as negative. This is acting in upward direction. This will be positive. So equation will become n minus 1200 cos 25 minus 750 sin 25 equal to 0. So from here we will get the value of n. So that value is 1404.53 newtons. Now we will find the maximum value of friction which is actually acting for this particular situation. So that value is Fm will be equal to mu s n. So how much is the coefficient of static friction given to us? 0.35. Put the value of normal pressure calculated in the previous step. So we will get the maximum value of frictional force which is actually acting for this particular problem. So answer for that will be 491.5 newtons. Now fourth step, we have to compare the frictional force required to maintain the equilibrium with the actual value of frictional force acting. Now you see the frictional force required to maintain the equilibrium is lesser than the frictional force which is actually acting in the situation. So it means what we will conclude, the block is in equilibrium. So we got the first answer. He was asking determine whether the block is in equilibrium or not. So answer is block is in equilibrium. Why? Because the frictional force required to maintain the equilibrium is very less as compared to the frictional force which is actually acting for this particular situation, for this coefficient of static friction given to us. Fine. So it means block is in equilibrium. So what was the next step we have to find? Then he says find the magnitude and direction of the friction force. Now we have concluded that block is in equilibrium. So we have already found that for maintaining the equilibrium this friction force is required. So answer will be to find the magnitude and direction of the friction force, that will be equal to the frictional force required for maintaining the equilibrium. That will be 172.58 newtons.